And so don't say anything you wouldn't want on a recording, but we'll be sharing the recording after the meeting. So let's go ahead and get started. Let's see if I can see everyone. Thank you everyone for joining. Thank you for folks who have their cameras on. It's really nice to be able to see folks' faces. My name is Susan Sanford. I'm with the Research Triangle Cleantech Cluster, and we are partners with Jules Accelerator on something called the North Carolina Cleantech Corridor. And by you all being in this meeting today, you are part of the North Carolina Cleantech Corridor Committee. And so thank you for being a part of this. We've got a really great group. We have thought leaders from San Antonio and CPS Energy based in San Antonio today. And then we also have world-class researchers from right here in RTP from RTI International. So what I'll do is maybe just give a little framing on why we're here, what we hope to achieve after 90 minutes, and then I'll run through the agenda and we'll get started. If you feel comfortable turning on your camera, great. But please mute if you're not muted. That'll be helpful. So again, we're part of the Cleantech Corridor, which has 3 legs on this stool. We will hear from Bob then if we have time at the end of the meeting, and Bob will share a little bit more about the accelerator. But today we are hosting a Cleantech Corridor Committee meeting, and that's a group of diverse stakeholders, utilities, industry, academia, government, coming together to identify shared challenges and to find solutions, whether that be from a startup, existing industry, a new business model, to create pilot opportunities across North Carolina. So that's the goal. And for today's meeting, if we at 3:30 have identified 3 local governments who want to pursue this conversation further, that would be success. But also we want to learn from each other and want you to develop connections with your peers. So use this as a peer learning opportunity. So that's a little bit about the goal for today. I think I'm still getting a little bit of feedback from someone. Let's see if I can. If you could mute, if you're not on mute, that would be great. So Jules Accelerator is a partner on this project. We are halfway through a 3-year U.S. Commerce funded project. Jules is a nonprofit, as are we, and we'll hear from Bob a little bit later to give you an update on this next class of startups. I wanted to share with you and thank you all for participating in our strategic planning process. We have, as of 2020, RTCC has a new vision statement, and you can see it here, but it's really to facilitate cleaner communities through clean tech innovation and adoption. And before we get started, I do want to thank our board members who provide the majority of investment in the Cleantech cluster, and that is matching funding towards this U.S. Commerce funded project. So thank you to the folks who are on the call who make this project possible. So with that, let's see, how am I doing on time? Okay, I think I'm 1 minute behind. Just really quickly, some of the folks we have on the call, I don't expect we will have time to do individual introductions, but I want to thank some of the folks on the call. We have at least 11 local governments, including new folks from town of Apex and town of Clayton. We have, I'll just call out a few people actually. City of Durham, we have City of Greensboro, City of Raleigh, City of Wilson, town of Benson, town of Cary, town of Chapel Hill, town of Holly Springs, town of Morrisville. And then from the state, I believe we have NC Commerce and DEQ. And from the federal level, we have Fort Bragg Military Base, the largest base in the country also here. So thank you to those folks, and then to our utility partners as well. And with that, I think I'll go ahead and introduce Emily Royale. So Emily is Smart City Coordinator from the City of San Antonio. If you all were here earlier, we were talking about Emily is an MIT educated urban planner, but she basically coordinates all of the technology projects for the City of San Antonio to provide public service to the residents and communities there, with a particular eye for keeping the side of transparency, security, equity, and accessibility. Did I miss any value there, Emily? Was that all of them?
No,
okay. And so I'm really excited to learn from Emily, and I will hand it over to you, and you can tell me when to advance. How's that?
Sounds good, Susan. Thank you. Good afternoon, everybody. It's great to see a ton of local governments here, outside of our state of Texas, and I love speaking to local government. So thank you for joining, and I appreciate you all taking some time. Jonathan and I from CPS Energy are splitting the time, so I'm going to be brief. So it looks a little bit like the PowerPoint is pretty different from the one I sent you. I don't know if there's a way to maybe make the screen color look a little bit different, or I could share my screen. Either way, Susan.
I can pull up your original PowerPoint. How's that?
Yeah, that sounds good.
And
so what I'm going to
go ahead. Well, I forgot to mention, since we didn't do introductions, if the folks on the call wouldn't mind just using the chat box to introduce yourself, we can use that as a way of collaboration. Go ahead, Emily.
No problem. So what I'm going to share with you all a little bit about is a little bit about our office and our Smart Cities program, which is called Smart SA. SA stands for San Antonio. And then dive into our partnership with CPS Energy, which is our municipally owned utility, to provide a pilot project for smart streetlights in 3 of what we call our innovation zones here in the city of San Antonio.
Okay, I have it. How's that?
Perfect. Awesome. Okay, great. So this is a little bit of a schematic about our office and how it's structured. Different offices, as you guys are, I'm sure, all very well aware, related to innovation, local government are structured in different ways. The way we look at it is kind of like a quadrant. On the far left, you'll see what we're calling really our enhancement-oriented innovation. That's about looking into city government processes internally and improving them, and really teaching a man to fish, so to speak, by embedding into our city departments out-of-the-box thinking, ways of innovating, and we use what's called our Innovation Academy to get that done. That's one of our program areas. On the far right is what we call anticipatory innovation, and so that's about really looking at the cutting edge, the frontier of emerging technology, and trying to address upfront, typically in collaboration with our local university system, what some of those emerging technologies are and how they might impact city services and our ability to deliver city services. Our program that's looking at that is called the Research and Development League, which is ultimately a partnership between our office and several of our local universities. So I imagine in the Great Research Triangle, you all have some similar programming as well in your offices. And then at the bottom is what we call kind of like our adaptive innovation, or our bottom-up grassroots innovation. This is really where we work with the community to try to drive what our strategic programming should be. We really focus on a community-driven model for innovation and smart cities in our office, and we have a program called CivTech SA, which is more or less our office's community engagement arm, focusing on building technology skills with our local community, students, and entrepreneurs in order to drive that change systemically. And then up top is the program that myself and our Chief Innovation Officer, Brian Dillard, run, which is called Smart SA. CPS Energy is one of our Smart SA partners, and this is what we call mission-oriented innovation. So it's really taking what the R&D League is doing and what our community is driving us towards with CivTech SA and executing tangible projects that try to deliver on that mission. Next slide, Susan. So I'm not going to read all this, but these are all various components to our strategy. We definitely have a big focus on data governance, for example, and scaling up. We learned pretty early on that it's very hard to invest up front in smart cities efforts with millions of dollars, and there's so much uncertainty at play. So we try to work on pilot-based projects and then develop a proof of concept from there and scale up. Go ahead. Oh, too much animation on this slide. One more time. Thank you. A little bit about our mission as an office. Our focus really is to harness power of technology and data and our residents and our community to help San Antonio become a connected, inclusive, and resilient community. Next slide. And of course, our partnership to execute that is called Smart SA. We have 8 partners in our Smart SA partnership, including CPS Energy, but also our water authorities. That would be the San Antonio Water System, the Edwards Aquifer Authority, the San Antonio River Authority. Water is a really big issue in our community. But then, of course, transportation. So VIA is one of our partnerships, in addition to our energy utility and local university system. Next slide, please. And we've got 3 focus areas, and you can just run through them real quick, Susan. The first one being access to services, ensuring that all of our residents have access. The digital divide is a big issue in our community, and one of our largest programming areas is working with addressing the digital divide locally. Next one. Mobility is, of course, another huge issue. We are a city that continues to sprawl and annex additional territory almost daily, and our primary means of communication or transportation in this space right now is single occupied vehicles. So we are definitely working on transportation as an important smart city strategy. Next slide. And last, of course, sustainability. And in this case, we really want to ensure that all of our residents are actively participating in citywide initiatives to conserve resources in our region. Next slide. And then we've got 3 innovation zones. And really what this is City Council in 2018 designated 3 areas where they charged our office to navigate this partnership to execute pilot projects in each of these physical locations. When you take a look at our whole city, you'll see that they're kind of like on an angle and an axis that kind of penetrates each part of our city jurisdiction. Next slide, please. The first one being our medical center, and that's just kind of like a map of the boundary of that particular innovation zone. Next slide. Brooks, which is a mixed use, sustainable community in San Antonio. This is really becoming kind of our frontier for innovation in our community. Brooks City Base is a former military base, now transformed into a combination of commercial, residential, and sustainable living. Next slide, please. And last but not least, of course, our downtown. If any of y'all have visited before, this is where the Alamo is. We have a ton of historic building stock in this area. And of course, we're trying to push forward for innovation as well. Next slide. So that's a little bit of context about our office and our programming. Now turning towards our smart streetlight pilot project in partnership with CPS Energy. I'll give you a little background on it, and I'm sure Jonathan will then kind of dive in and take you guys through some more details. So this is a partnership between our Smart SA partners, CPS, and ourselves. And what we did was we asked or submitted an RFP earlier this year for a vendor to demonstrate 5 use cases for smart streetlight technology in each of our innovation zones. We signed on with Itron, and Itron will be starting deployment in September of cases on smart streetlights. To give you a sense of what those are, They are primarily for sensors, including air quality, temperature sensing, parking sensing. So I learned this recently. You can attach a sensor onto a streetlight and it can detect the availability of parking nearby, which in turn can be folded into an application that you can deliver to your residents. Ambient noise detection, and the last one is flood sensing. And I think go back maybe just one, Susan.
Yeah, I think I had happy fingers here. Okay.
No worries. Okay, so as far as how this RFP is structured, we're starting by demonstrating those use cases on at least 15 lights in each of those 3 innovation zones that I showed you. A big priority for us is to make sure that the data that is generated from this pilot is open and accessible. And then, of course, we're going to deploy it in September. Once we evaluate that pilot for about 6 months, we'll then determine whether we want to go citywide with that solution. As you can imagine, there's a lot of use cases there, and each of those use cases may have different applicability for different neighborhoods. So we're going to be determining where we want to apply those use cases in particular. Next slide. Now, I understand for this group, a focus of interest is air quality, so I'll give you a little bit more information about our air quality use case in particular. The goal is to measure key urban pollutants, particulate matter, nitrogen dioxide, ozone, and air temperature, as well as humidity and dew point. A big question for us is calibration. We do have some existing sensors that are already measuring some particulate matter that our health authority is monitoring, so we want to make sure we calibrate it with that, but of course with an EPA standard. We're looking for real-time historic data. We're asking our vendor to provide us a map of those locations, and of course the data that emerges from it to be accessible on a platform that's publicly accessible, and then also to provide automatic firmware and software updates. Next slide, please. And this is just kind of a high-level schematic of what our subcontractor has proposed to us. We're working with Aeroqual on behalf of Itron, and this is a little bit about how the sort of cloud and internet-based diagram of this project is going to work. I'll give you guys just a second to digest that. But ultimately, we do have an access point and a photocell that's integrated with a communication module that's actually attached to the streetlight. And that's how we intend to monitor our particulate matter. Next slide. I think that's it for me. Of course, if y'all have any questions, please don't hesitate to reach out. You can find us on Twitter, InnovateSA, and our website, which I am not gonna lie, is super outdated. We've been so busy with all kinds of stuff that we haven't really paid attention to our website. But please don't hesitate to reach out to us over Twitter. We're pretty responsive. Thank you all for your time, and I'll pass it off to Jonathan.
Thank you. Some feedback, if you could mute yourself. Great, thank you. Emily, thank you. I know we're going to lose you at 3. I might follow up with you offline. We have a community interested in restoring historic buildings and making them more sustainable. It sounds like that's part of one of your innovation zones. So with that, let me introduce Jonathan Tijerina. Let me pull up our other presentation. Yeah. I have a nice little intro teed up for you, Jonathan. Jonathan is Senior Director of Business and Economic Development, right, for CPS Energy, has held multiple roles. You can just look away while I advance these slides. Has held multiple roles, clearly being cross-trained for multiple leadership roles at CPS. I looked you up on Twitter, Jonathan. I was looking for a photo for you, and I saw this picture of you wearing socks with your daughter's picture on them. So Jonathan's also good. So anyway, thank you for making time to be with us today and share this city utility partnership.
Sure, Susan, thank you so much. And yeah, that's actually like my new favorite photo of my daughter and I. It's pretty fun. Susan, thank you first and foremost, and thank you, Emily, for joining with me today as well. And I just want to take a second to also thank Itron, who's been one of our key partners over the last, almost 9 years now, going and helping us basically enable what we think is a interesting story here in San Antonio and what we're trying to do from a smart city perspective. I'll be honest, I'm having a little bit of a delay on my screen here, so I'm just going to refer to my slides by number, and hopefully those will pop up for you all to see. But just to start off here on slide 2, to give you a little bit of a background as to who we are as a utility, CPS Energy is actually the largest and one of the oldest utilities in the nation. Our business actually goes back to 1860 when we were a natural gas company. We have been municipally owned since 1942 and basically serve as the vertically integrated utility for the San Antonio area to include our county and a little bit of portions of the surrounding area. On background, we have about over 875,000 electric meters and about another 360,000 gas meters. That actually provides energy and resources to about 2 million customers if you look at just total population of our area. So we're a pretty big utility in the scheme of our planning and where we are from a development standpoint. On slide 3, Susan, if you could go there, just talk a little bit more about facts about us. We do have one of the premier credit ratings in the industry at AA+. And the reason why we highlight that is because that really has enabled us to think differently about how we interact with our business partners to figure out how we ultimately deliver solutions from a product and services standpoint, or even just from a reliability standpoint for our customers. And then just some key facts here, about 3,100 employees, about $11.2 billion in assets, and we do about $2.5 billion in revenue per year. You can go to slide 4. Talk a little bit more about how we got to the point where, you're seeing us partner up with like our owner, the city of San Antonio, and the other municipal partners that Emily referenced about. But in reality, the utility industry as a whole is really going through probably some of its biggest technological changes ever, right? So if you think about just the past, it was pretty simple, right? You built it as you needed it, right? You built out generation, you had customers for the long haul, and you were always just kind of working your way towards meeting the supply and demand. What we've done now, going back to 2017, is that we implemented a path, not a strategy necessarily, but it's a path around flexibility. And really what we're looking for is we want to be able to have the flexibility to incorporate new technology that includes not only products and services for our customers and benefits for our community, but also how we think differently about our generation fleet. And so we want to think about how do we basically balance the tried and true with the new. And what we mean by that is we do have fossil generation in our asset base. And so how do we incorporate that and retire those assets responsibly while ensuring that we maintain our high service of reliability and taking into consideration all of the air quality concerns that are out there around generation power plants. Since 2010, we've actually been on a mission of reducing our emissions, and we've reduced about 65% of our emissions by incorporating more solar, more wind, and from a national standpoint, we actually just were recently recognized as one of the shining cities in America for having the most solar. We actually have about 510 megawatts of utility scale solar in our portfolio and about another 120 or so in the distribution generation standpoint. So, we have taken some very aggressive steps as we move forward to figure out how we balance all of these new technologies while ensuring that our customers are protected from pricing and ensuring reliability. You can go to the next slide. Talk a little bit, I'm going to spend probably most of my time here, talk a little bit about this flexibility that I talked about in this flexible path. Really one of the primary backbones of our planning and our perspective to move forward really is our communication network that empowers our AMI technology. So this is the network that we built out in partnership with Itron, where we're able to have two-way communications to our devices via the electric meter and our gas module and the gas meter. We built it with the mindset that it would help us enable components of the smart city that included the possibility for air quality sensors, smart street lights, more distributed generation resources, electric vehicles, and so on. And so really what we've been trying to do is put that plan into motion. And it's because of great partners like the city of San Antonio and other other municipal utilities that we're able to think about how do we approach this, because at the end of the day, we share a common customer. And so selfishly, I'm from the mindset that I believe that San Antonio is very uniquely positioned to really put forth a plan in motion that would be very beneficial and rewarding because of the possibilities that we have, considering that the city not only is managing the city government perspective, but they also have insight into the electric and gas utility, the water utility, transportation, and even some housing. And so again, just all of these different variables playing into the equation as we think forward about how do we ultimately help reduce our emissions while ensuring, again, at the forefront, reliability and our resiliency to the grid. For example, today it's 127 here in San Antonio, and it's a beautiful 102 degrees. And we got to make sure that our air conditioning units are up and running, because being out in 102 degrees for more than 5 minutes and you'll be not a very happy camper. So if we can go to the next slide, Susan. I'll kind of wrap it up here in the next 2 minutes here. Just to give you an idea, this is a product roadmap that we have in flight that we're looking at, again, about how do we, in essence, think about air quality differently. For us, it's not just about having sensors and using that data to make decisions, but it's also putting into motion these products and services that ultimately enable us to think differently about how we are, working as a utility. And so you'll see here over the next 3 quarters for fiscal year 21, we're putting into motion quite a bit of things that would help us reduce emissions, rather from a vehicle standpoint, bringing in some additional green tariff options and availability for our larger commercial customers, and even thinking differently about how we offer resiliency and how do we incorporate more renewable or low-emitting technology into that aspect. So this is just kind of a quick snapshot of actually what we have planned in the future. And then the last slide I'll mention is, I talked about us being a leader in renewables between our solar and wind generation, and we do all of this from the perspective of these guiding pillars. And so you've heard me say a lot about resiliency and customer affordability, our environmental responsibility. All 7 of these pillars really play into the forefront of any strategy that we put forward. And so you'll see that as a utility, we're not only strategizing and making decisions that are, financially responsible, but we're incorporating these additional 6 pillars to deliver what we're ultimately looking for. And actually, I guess the next slide is the last slide. Just quickly, I'll also talk about, and so moving forward, we're still putting all this into motion. We recently launched an RFI where we are actively looking for some feedback around adding some generation resources to our mix. We have some traditional fossil fuel plants that are coming up to the retirement age, and so we're making progress into replacing those. We're actually going to be going to the market later this year with an RFP that will seek up to 900 additional megawatts of solar, up to 50 megawatts of energy storage, and up to 50 megawatts of a gas tolling agreement or an equivalent firming up capacity. And so we really believe that when you throw that into our mix, you'll see how we'll continue to evolve our generation portfolio that ultimately reduces emissions, while incorporating a smart city where we're going to be looking for additional products and services to plug and play into our network that ultimately will bring efficiencies to our customers. And so I know I went a little faster, but I wanted to be respectful of time. So I appreciate, again, you all having us today, and looking forward to any questions we may have later on. Thanks.
Thank you, Jonathan and Emily. Let me just do a quick ask of Jonathan and Prakash, since we're going to lose Emily at 3. Do you gentlemen mind if we take time to do a little Q&A, and then we'll go into your presentations and do Q&A after yours? I think that might make the most sense. We can pick Emily and Jonathan's brains. Real quick, Jonathan, do you have that RFI? Is that already published? Is that something you can share? I'd love to share that with our network.
Yeah, the RFI is actually already out. We're actually in the process of receiving responses and evaluating. The RFI really was more for just a market intelligence snapshot. As a municipal utility, we have to be very careful about how we, kind of acquire information. But yes, the website is actually up and running here at cpsenergy.com/flexrfi. And there you'll find some background information, including the full RFI document.
Thank you very much. Okay, let's just take some time and just open the floor for anyone who has questions for Emily and Jonathan or Jonathan. Might have to unmute yourselves. And I neglected.
Yeah, this is.
Oh, go right ahead. Go ahead.
This is Greg Sponseller from Raleigh. Emily, I was just wondering if we could spend a little bit more time going over those 4 innovation groups that you had described, and if you could share a little bit more about how those were created and sort of the impetus behind sort of what role they're serving with the city with regards to developing some of those innovative projects.
Yeah, certainly. And are you referring to the use cases for the smart streetlights?
It was that, like, the CivTech group and those 4.
Okay.
I'm not necessarily specific to that group, but
yeah, sure. How the office was structured. Yeah, there's like 4.
Is there? I guess is there? It sounded like those were sort of some of the public groups that were affiliated with that. Is that correct?
Yes, so they're internal in the sense that those are basically 4 departments that are run by our office. So Smart Cities, Smart SA, that was at the top, is one of our programs. It's run by our staff. Same thing with the Innovation Academy, which is really, those are just really the brands for the type of work that we're doing as a whole Office of Innovation. Now, originally, our office was called the Office of Innovation and Reform, which basically meant that we were kind of like an auditing arm for the city. We would go into departments, we would make recommendations about streamlining operations and making them more efficient. That's what the city treated as innovation in the early 2000s. In the last 5 to 7 years, we've really evolved quite a bit as an office, and those really those 3 areas, the Smart SA, R&D League, and CivTech SA, those all emerged after the Innovation and Reform title was changed to be just the Office of Innovation. The way this was developed was fairly organic, to be honest. The first one to get started was CivTech SA. So there was this idea that rather than focusing all of the office's efforts inward, we really should be engaging with our community directly to drive the strategy of the Office of Innovation as a whole. And then Smart SA branched off of that when City Council approved via our city manager about $5 million, or actually it was $7 million in 2017 for smart city efforts. So that program was built off of that funding, and that was what was, enabled the hiring of myself and our Chief Innovation Officer, for example. And then R&D League is only about a year old, and that really comes from as the Smart Cities project started executing projects, we realized there's so much emerging technology out there. We really need to be building more partnerships with universities to get ahead of the game on what comes next. So Smart SA is really focused on getting it done, getting it in the ground, all of those efforts. R&D is really thinking, okay, what's the next, pillar of work that we need to accomplish? I hope that answers your question.
Yeah, very much so. And if there isn't another question coming up, I'd be very interested to hear about the relationship with the students and how those things sort of came about and how that is working. But I'll be quiet for just a moment.
So Greg, I'll direct you to civtech-sa.com. I'll actually put it in the chat, and you can learn all about that program there and how that works.
Super. Thank you very much, Emily.
No problem.
This is Prakash. I have a question. I'm curious to hear about the air quality sensing that you have planned on. Do you have kind of specific plans on how the data would be used along with the temperature, humidity, noise? Is it part of kind of a larger plan as part of the Smart City program?
So yes, there's twofold. One is our established use case for how the data should be used, but then given that it's a pilot, we're really open to learning from this process to determine other applications for that data. Now, that use case came from our health authority and our Office of Sustainability. So to backtrack, those use cases were predetermined by our city departments. And what our office did was really put out almost like an open call to city departments and said, we have this opportunity to make our streetlights smart. What kind of technologies could you imagine being adapted to a streetlight infrastructure that was running online? And our health authority came up with, we really want to detect temperature to determine urban heat island effect in our community, and then secondly, air quality. We had around that time, actually, the city of San Antonio and Bexar County, our air quality level had been degraded a notch. So I'm not sure what exactly, I think our ozone level. So that became a really critical area to try to gather and collect more data and more information around. In addition to that, there are applications that emerged from our climate action plan, which was passed last year. And the climate action plan really sets forth certain commitments that the city of San Antonio wants to make, as in particular in terms of air quality. And obviously we can't do that if we don't have data to do that. And we can't gather that data if we don't have infrastructure to gather that data. And right now we have several sensors and sort of stations in our community that are collecting that. But it's not enough, right? So we wanted to leverage this opportunity to enhance and supplement that. And a big challenge of this work is going to be integrating that data with the existing monitoring that we're doing.
Thank you, Emily. That's very helpful and very interesting. How many sensors did you say you are kind of deploying at the moment as part of this pilot?
Yes, so for air quality, there will be one sensor on 15 lights in each zone, so 15 times 3. Now, when we look at citywide deployment, that's about 119,000 nodes, streetlight nodes. So at that point, when we decide to go citywide, it will be a question of cost and location. So how many do we really need to triangulate appropriately where we're sensing? But then, of course, what are some of our cost limitations and how do we balance that out with the other use cases that are competing for budget, right?
Okay. Thank you very much.
Yeah, no problem.
Just maybe we'll have time for another question. I just want to nudge some of our utilities folks if you have questions for Jonathan or if anyone else has something burning to ask. Nope. Okay. Congratulations on passing that climate action plan. I know a lot of our local governments are in the middle of that process. I think
it wasn't. You know, you can imagine in Texas as well. Like it was an ugly process, but we got it through, and it's been great because it's given us a lot of justification for work like this.
You know, that would be a really good module in a Smart Cities conference. You know, sort of how do you project manage passing a climate action plan? But congratulations on that, and then also CPS on the reduced emissions, a really, really aggressive goal. I think we'll go ahead and move on since we have, and you know, if you stick around, please, as long as you like. You know, you might develop a connection or an opportunity with RTI International. But I'll go ahead and introduce Jonathan Thornburg, and let me tee up your slides. Jonathan is, gosh, I have it right here, Director of Aerosol Research. He has a fascinating background. Director of Exposure and Aerosol Technology at RTI International, has a PhD. I didn't even know UNC Chapel Hill had this. A PhD in Aerosol Physics and Engineering from UNC Chapel Hill. And very recent research, Jonathan, correct me if I'm wrong, that you just completed, involves studying emissions from secondhand emissions from electronic cigarettes to measure how many meters and what type of particles are being emitted, which sounds like a fascinating study. And I imagine you are very popular right now in the time of pandemic. So with that, Jonathan, thank you so much for joining us. And Jonathan, I think, is going to give us an overview of how you can use this technology at the neighborhood level. And then Prakash will share some research and NASA-funded research that is being done in Los Angeles and also here in North Carolina. So please correct anything I might have misspoken.
No, that was a great introduction, Susan, and hi everyone. I'm happy to be here today. I guess as Susan's, you got to tee up the slide, Susan.
Yeah.
Okay. While she's doing that, I'm going to give just a brief overview of 3 slides of a kind of a survey we did on the value, perceptions, and barriers regarding cities and municipalities, installing an air quality sensor network. So we did this work a couple years ago, and what we did, we developed some hypotheses that led to a development of a questionnaire that we sent to 50 city and county governments from across the USA to test our hypotheses. We also had 10 follow-up phone calls with a couple of the government's agencies, and then we used that information to revise our hypotheses regarding the value of the air quality sensor network. So we can go to slide 2. So these are our final sort of value proposition hypotheses we came up with. So it's these types of networks can provide the cities, the government's historical and real-time data to identify pockets of poor air quality. From the historical perspective, it's what policy changes can be made to improve public health, reduce environmental impact, or improve quality of life for the citizens of that municipality. And I think Emily did a great job covering all that already. From a real-time perspective, I guess I'd just like to add that it can warn of the public of air quality emergencies. And obviously I have a picture of a giant industrial fire here, but it could be something as small as a residential fire or maybe a traffic jam that could impact the air quality of folks living in that specific area. Next slide, please. So from the perceptions part, from the results from the survey, we kind of take-home messages were is that if a city had or the municipality had good air quality, there really was minimal public or political pressure to install a low-cost sensor network, air quality sensor network. There was, it wasn't until cities or the municipalities kind of were reaching towards that reached non-attainment status that there really was a desire to do something to solve the problem. That usually included installing more air quality monitors. That was a very reactive approach. I think municipalities could do a much better job being proactive and installing these networks ahead of time to identify air quality hotspots that could eventually drive them into non-attainment status. Another thing we noticed is that if cities did have either a regulatory grade air quality monitor or a network of low-cost sensors, they really didn't see the value of the data and how it could be applied to improving the quality of life of their residents. And I think mainly that was just they were just unaware of how you can link air quality to decision, to urban planning decisions or public health decisions from the health department. However, we did kind of an offshoot of this. We did a small secondary survey, asked others, folks that might be residents of these municipalities, what their thoughts would be about having access to the sort of air quality data and information. And kind of the mixed results we received was, families were very positive about having access to this data. They want to know whether their houses or their children's school was in an area of good air quality. Realtors,
Hey,
we
Jonathan,
also talked to realtors. They gave a very mixed perception. Yes.
You're breaking
Yes.
a little bit. I don't know if it's on my end or is anybody?
I also experienced the same thing. Yeah.
Maybe turning the video off might improve the.
Okay.
Thank you.
I'll lean closer to the microphone. Sorry. Sorry about that, everybody. Yeah, anyway, so realtors gave a mixed perception. And then we also talked to a couple health and property insurance agencies, and they all gave negative responses, like they didn't want access and saw no value in that data. Next slide, please. So Emily already discussed a lot of these, the kind of the barriers that people saw, were infrastructure and some of the maintenance issues. And there, as Emily just described, there's simple solutions that can be easily applied. However, the one thing she didn't mention was sensors, air quality sensors do fail. And unfortunately, when that happens, you do have to send somebody out to climb a pole and replace that sensor. Surprisingly, when we asked about barriers, the cost of this air quality sensors was never an issue. There was the willingness to pay, we found was $1,000 or less per sensor, or sensor package. So that was that did take us by surprise. So I guess that's my brief summary of the values of the network, perceptions, and the potential barriers. And I guess we'll move on to some environmental justice case studies. So next slide, please. All right, we can go to the next one. All right, so there have been numerous environmental justice studies conducted across the United States. Imperial Valley, California has had a major one, multiple studies in Los Angeles, as well as another in Kansas City, just to name a few. This is I'll be talking about an RTI-led study in Denver, Colorado, just very briefly. The whole point of this study was there's a mixed residential and industrial area surrounded by a couple Superfund sites that has predominantly Hispanic younger families, but they also have a high chronic disease burden. We're talking about asthma, hypertension, early onset COPD, etc. We're just starting to wrap up the study and summarize all our findings. But so what we found to date, though, is that the state monitor, which is kind of off to the far left of the map, does not detect concentration extremes that occur within the environmental justice community, as shown there on the map. And on top of that, there's the two major interstates that run through these neighborhoods. Because those interstates are constantly busy, 24/7. The traffic-related air pollution is very consistent and constant within that environmental justice community. But if the air pollution concentrations near the industrial sites, which are the red dots, are extremely variable. And that could have we've learned from this project that variability actually is very concerning to the residents that live near those sites. So that's, I guess, all I want to say about that study real quickly, and I'll turn it over to Prakash, and he'll talk about his urban and regional scale study.
Thank you, Jonathan. Hello, everyone. I'm glad to be here. I'm an air quality scientist here at RTI, and I'm going to be talking to you today. I want to share a little bit about the NASA-funded study that I'm leading. It's an example of, it's a practical example of a low-cost air quality sensor network. And so as part of this study, we are deploying sensors using citizens, volunteer citizens. Generally referred to as citizen scientists. And the goal is to generate spatially and temporally resolved data. And so what's the driving force for all of this? To manage air quality, obviously you need to know what's the air quality like and what the sources are. Obviously, there are these the reference methods that are deployed by the regulatory agencies. Those are accurate. That's a gold standard. However, they are spatially sparse, and that's also expensive. And on the other end of the extreme, you have these low-cost sensors that are relatively cheap, almost 1/10 of the. Sorry, it's about $200, $250 per sensor. So there's the potential for broad spatial coverage. However, the disadvantage or a limitation is that it's less accurate compared to these reference methods. And I'll go a little bit into that in the following slides. And in the middle, you have the satellite data, which offers the global spatial coverage. And they do have products that estimate what the particle level concentrations are on the ground. And those algorithms use the data from these monitors, the regulatory agency monitors, to calibrate the data set because the satellite data is looking through the entire column of the atmosphere, and it's not what people breathe at the surface. So there's some sort of calibration that's involved using these monitors. And so the idea here is, can we increase the spatial resolution using these low-cost sensors? Are these low-cost sensors accurate enough or reliable enough to be able to do that? And so that's kind of the whole goal of this study. Next slide, please. And so if you could go back. Oops. One more slide. Yeah, that's right. And so as part of this study, what we're doing is we are deploying low-cost sensors in 3 regions. Sorry, these go back, please. Yeah, nope. Right there. Yeah. So we're deploying the sensor network in 3 regions, Los Angeles, here in the Raleigh Research Triangle Park region, as well as Northern India. The sensor that we're using is the commercially available low-cost sensor called as Purple Air. And the Purple Air has existing infrastructure that makes it easy to use. It communicates by a wireless internet connection, transmits the data to an open source data platform, and that's also available on the web for anyone to look at and download the data. So you have the ability to look at historical data as well as real-time information. And so the idea behind these 3 regions is to kind of look at the performance of these sensors in different regions with different particle composition, because that impacts the performance of the sensor, as well as looking at a range of particle concentrations. Los Angeles may be on the high end as far as US is concerned, but on a global basis, Delhi, the North India obviously is way more polluted. And so we kind of picked these 3 regions to represent the high, medium, and low end, and Raleigh region representing almost clean conditions, very low PM 2.5 concentration. And as of now, we have about 150 sensors installed in the Southern California region. We have about 30 sensors installed here in the Raleigh Research Triangle Park and surrounding areas. We have 70 more planned for this region, and we are about to begin deployment in the Delhi and surrounding areas in North India. Next slide, please. And I mentioned a little bit about the sensor performance, the accuracy, the need for the low accuracy of these sensors compared to the reference monitors. And so what the slide shows here is that we compared the many of these low-cost sensors against a reference monitor, and the key take-home points are that the sensors track the reference monitors very well. They are highly correlated. You can see on the top right the correlation coefficients of 0.95 and greater. And so they're highly correlated. However, they are about 10 to 30% larger than the reference monitor. In other words, so they have that bias. So But the high correlation means that these sensors, the data can be adjusted or calibrated to be equivalent to these reference monitors. And one thing that we found is that the calibration is recommended in the region of interest, wherever you're deploying. And so we have, since then, we have performed this calibration here locally in the Raleigh region, as well as in India. And the other thing that I wanted to kind of show, the bottom graph there, is that these sensors, again, track the reference monitors. The blue line is the reference monitor, and the other colors are the sensors. And it's sensitive enough to capture the weekday, weekend variability. And so that, that's influenced obviously by the people's workday schedule, vehicle movements, and so forth. So it's able to kind of pick up those signals. Next slide, please. And so what this type of tool then provides us is the ability to evaluate spatial gradients and impact of maybe specific events. This is a snapshot from the Purple Air website, just for the US, but we have like this sensors pretty much throughout the world that's been deployed. This was taken today at about 1:10 Eastern time. And you can see that the PM 2.5 concentrations in the California area is quite high. I think there's some fires going on. And of course, we are in the moderate air quality region here. Next slide, please.
There is a little red dot in the triangle there. It looks like.
Yeah. Yeah, so, I think those are like, and so that's kind of goes into the quality assurance of these sensors. So we'll have to kind of determine whether that's a real data point or if the sensor is not measuring properly, right? And I'd be happy to go over those in detail later on. And so kind of, so the ability again to kind of look at these different types of events. So we am presenting here a couple of examples. So on the left is a graph of how these sensors responded to the California wildfires back in 2017. So this is something that we published in GeoHealth, and the link is there at the bottom there for the left. And so you can see that the sensors were reading about less than 20 micrograms per cubic meter before the fires, and during the peak fires, the 24-hour average concentrations, the daily average concentrations reached more than 100 micrograms per cubic meter. And then again, they reduced after the fire. And on the right is a snapshot of the map, again, this July 4th. So even though there were, many regions did not have the official July 4th fireworks, residents chose to burn crackers. And so this kind of tells you the impact of that on air quality. And so you can see this was taken at, this snapshot was at around 9:50 p.m. Eastern time on July 4th. And so you can clearly see the impact of the fireworks there. Next slide, please. So, so what can we kind of do with this type of sensor? And I think that kind of gets into the discussion that we have for the Q&A session and the expanded discussion. Potential applications that we can think of, obviously based on these case studies, we can see that these sensors are performing reliably. It's been operational for more than a year now. We are getting reliable data as long as there's wireless internet connection. The data completeness is good, and they are well correlated. So these sensors have pretty good applications for potential for different types of applications. And a few that I can think of here, are like a dense network for urban and neighborhood scale monitoring, if that's of interest. Jonathan mentioned about environmental justice area. So if this is something that you would be interested in doing, then obviously this sensor would be helpful. Any specific hotspot regions that receive a lot of complaints of poor air quality, high particle concentrations, and you want to evaluate what it looks like. At traffic intersections, like Emily mentioned, to look at the impact of air quality at these different junctions. and maybe even air quality monitoring or management during large events, like maybe during state fairs or large football games, those types of events where you will have a lot of traffic, a lot of people movement, and so forth. And from a city perspective, perhaps potential integration with other systems for maybe dynamic management and control. A couple of examples that I could think of is maybe air quality forecasts, or maybe even into the traffic management system. If there is congestion at one place and you see the air quality getting bad, perhaps integrating it with that system to divert the traffic through a different route. So that's some examples there where these types of sensors could be helpful. And obviously, when you're thinking of locations other than home or office, you will need Wi-Fi connection, power. And so on the left is a figure of a picture of a solar panel retrofitted sensor that we did here at RTI. So that's one of the poles at RTI. It's completely independent of the grid. It's powered off the solar panel, and there's a cell phone inside that box there that transmits the data through to the Purple Air website. And so it's totally off the grid. You don't need any wireless internet connection or power. Obviously, it's the data plan that you would need to kind of make this totally off the grid. So I think that's the next slide, please. I think I have just the contact information there. Yeah, so that's brings us to the end of the presentation, and let me kind of stop there. And John, did you want to maybe add a little mention about this last slide?
I'll just quickly, just that there have been some early adopters and from city and governments and some nonprofits. So Pittsburgh is the top left, Los Angeles on the top right, Seoul, Korea on the bottom left are all have extensive networks already, and Clean Air Carolina, I think just recently achieved their goal of 100 purple airs, at least one in each county of the state. So that's it. Thank you, Susan.
Thank you, Susan.
Thank you. That was thank you for going into the applications of that, Prakash, and also Jonathan for sharing the research. I have a bunch of questions, but for the folks we still have on the call, and we often lose people right about 60 minutes. It's tough to hold a 90-minute call, so I should think about the agenda for the next meeting. But we still have plenty of utilities folks on the call, city staff, and then also communications experts, like Verizon. We have Itron on the call. So let me just open up the floor to ask what questions you have for Prakash or for Jonathan.
Hi, this is Crystal from Verizon, and thank you very much for the air sensor information. And when you talk about air quality, and it seems kind of is it just carbon dioxide? Is it what all goes into the actual measurements of whether the air is clean or not? Is that multiple sensors or multiple things that you're measuring?
Thanks for bringing that up, Crystal. Sorry, I forgot to clarify that. So the specific example that I mentioned, it's just particle concentration. So that's PM 2.5. It's commonly referred to as fine particles. But typically, obviously, it's when you look at air quality advisory, it's for the criteria pollutants that EPA defines. And most often in the US, at least, it's either ozone or particles that usually fall above the standard, and that results either in a health advisory or some poor air quality resulting from either of those pollutants. But the specific example that I mentioned, this case study, it's just PM 2.5.
Just particle. Thank you very much. I appreciate it.
Other questions for John?
I guess just a quick.
Go ahead.
Oh, I'll just a quick some quick additional information. When it comes to low cost sensors, particles and nitrogen dioxide are the, I guess, the most accurate and precise types of sensors. You know, when you get to and carbon monoxide as well. But you know, ozone is difficult to measure with a low cost sensor, but its technology is rapidly advancing. And then so unregulated compounds like VOCs, for example, there's still a lot of work to be done to develop low cost sensors.
This is Anna Murphy with Holly Springs. We have a wastewater treatment plant in our town, and we have a landfill in our town. So what would be the emissions that we would want to track? And have you guys ever dealt with a case study that is specifically around either of those uses?
So I heard the wastewater treatment. What was the other one?
And a landfill.
A landfill, okay. Yeah, in both of those cases, I would think probably the volatile organics is probably would be something of interest to look at. From a landfill, of course, if you have fires, then maybe a particle sensor would be also be helpful.
Okay.
What else can I think of? I think those are the two main things that I can think of. John, anything else that you want to add?
Yeah, I would say, you know, I think for both a landfill and wastewater treatment plant, a common complaint would be nuisance odors, and those are difficult to measure and track.
Okay.
Yes,
because you're correct in that.
Those types of odors. Yeah, and those types of nuisance odors, it's usually it's a very subjective complaint. You know, so some people are offended and others aren't. But definitely with the landfill, you know, you're looking at, you know, the diesel emissions from and resuspended dust from, you know, the dump trucks or the trash trucks, as well as the instrumentation or the equipment used to bury the trash on a daily basis.
Okay.
So that would be a particle monitor.
Right. And the VOC measurements that I mentioned would kind of help probably at least identify if it is any organic related odor, then that would help identify that. And if you are interested, if you want to sign up as a citizen scientist for our project, we could probably provide one of those purple air sensors if you want to use it maybe near a landfill or something.
Okay, I can follow up to get more information about that.
Sure.
Thank you.
Thanks. That's a great question, Anna. I thought Brennan commented in the chat that Orange County doesn't have a sensor on that EPA network, so they might be interested as well. Other questions? And I want to kind of remind folks that the reason we're talking about air quality today is at our last meeting where we were talking about smart cities. You know, we asked if you had a magic wand, what smart city solution would you want to deploy? And a lot of folks said we'd like to measure air quality, you know, for different reasons. So maybe I think Anna provided a good segue. You know, if you could measure air quality in your community, or if you had a magic wand at your fingertips, what would you want to measure? You know, what use case or where would you want to measure air quality? For folks to chime in.
So this is Greg and Raleigh. I think, you know, I'm very interested in sort of just digging into what the network of the purple air sensors that you've deployed in the area are actually sending you, and sort of where they're located. I know we were particularly interested in measuring air quality and temperature in the downtown area, related to a lot of the things that San Antonio had been doing, just to look at heat island effects and then air quality, you know, during particular times of the year, particularly associated with transportation. So I think as we think about this, you know, my first thought after hearing that you are doing this in the Triangle area is how we can connect with you to help build out your network of sensors to get more localized data in some of these particular areas, to look at trends and the disparities between particular areas of our community and others. And then also overlaying that with some of the equity data that we have in terms of low middle income families, communities of color, and things like that. So I know those are some of the correlations we're looking for, but definitely downtown with regards to the health benefits, and then also the environmental justice components.
Thank you, Greg. That's very helpful, and I think we could probably follow up separately, and I would be happy to maybe discuss this further.
Yeah, could you, Prakash or John, maybe add a little more of that? And thanks for sharing that, Greg. How could this group help you build out that regional network? Because I think so far we've heard Greg, Terry, and Carrie is like, me too. Brennan and Orange County is like, hey, over here, Anna and Holly Springs. How could this group help you? Is it a cost factor, or are these like $1,000 a pop, or is it just that we need to convene this small group and roll up our sleeves and just plan?
Yeah, thanks, Susan. So specifically related to this project that I mentioned, it's basically identifying locations where where we expect spatial gradients, where we expect the concentrations to vary significantly, and of course where we have access to power and wireless internet connection. And like I said, the idea behind that project, it's mainly to have local citizens deploy these sensors. So that's the citizen science aspect. So we are recruiting citizens who are willing to host these sensors at their home or office or any other location where they have access to power and wireless internet. So as far as that project is concerned, yes, if you're interested, definitely send me an email. Then we can kind of go over, see which location you're referring to, whether there are sensors already, or if there is a gap, then definitely I think it would be helpful to put a sensor there. And if we check off the boxes for all of these different things, then I think we should be able to do that. And like I said, we have distributed about 40 or 50 sensors, of which about 30 sensors have been deployed. And so we are planning to, total of 100 sensors are planned for this region. So I'd be happy to definitely discuss with anyone who's interested. But taking it beyond that project, if we want to expand, and so I guess another limitation there is, since the project is driven, it's funded by NASA, and the overall goal is kind of being able to relate it back to the ability to calibrate satellite data. Some of the locations that we pick may be limited by whether it's going to help us satisfy the science objectives that we want to do as part of that research effort. But beyond that project, if we want to expand this network, I think this, like I said, if the sensor just costs about $250 per sensor, and we can definitely expand this network further to kind of address many of these questions or specific questions of interest. John, anything more to add?
Yeah, thanks for sharing that kind of short term. Maybe we can help with convening a small group, and then kind of longer term, larger regional plan. I know we've got Duke Energy on the call, which is a service provider in a lot of these cities, who could maybe ensure these sensors are powered and have access to wireless. Do others want to chime in on your best use case for air quality sensing solutions?
Hey, Susan, I have a question. On the last one about how is air quality data shared, with this network, is there a, I mean, can it be shared through like a REST, I mean, is it being shared through like a REST endpoint or some type of API or something where we could pull the data to our systems?
Yeah, so the data is available publicly on the Purple Air website. I cannot, Susan, if you could allow me to share the screen, I could maybe go over the website if that's of interest. Otherwise, I can obviously send that information later.
Yeah, we can do that.
Yeah, I guess while Prakash is pulling that up real quick, this is Jonathan, to say that a lot of these APIs, it gives you access to the data, but I know it doesn't necessarily give useful information to the public and helping them make decisions. Just looking at the map Prakash is pulling up, there's a lot of colored dots, and a lot of times, folks don't know what they mean. They may know, yeah, they see the purple and they know that's bad, but they're not sure about the yellows and the oranges. So there's a big effort to try to simplify and make it more understandable, how to present this air quality data to the general public.
Yeah, that's a very important point, John. Yeah, thanks for mentioning that. So this is the Purple Air website that I mentioned. So the sensor transmits data directly to the cloud server that Purple Air hosts, and as you can see here, the data. So each of these circles is a sensor, and it kind of shows what the concentrations are for the different parts of the US. And of course, if you zoom out, you can actually look at pretty much even in other parts of the world as well. And in the right hand corner, so you can see here there's an ability to download data. If you click this, then it will take you to once we kind of zoom into the location of interest. And if you do this, it's still larger. Okay. So here it's in the Raleigh area. Let's see if it allows now. Yeah. So it kind of takes you then to the different sensors that are installed, and you can then specify which ones you want to download, and you can just download all of these sensors. Yeah. So that's kind of an example of the ability to download. Just even without downloading, if you click a sensor, it kind of gives this ability to look at the trend over the past few days. You can change the averaging time. Here right now it's default as 10-minute average, but you can change it to other time averages. But yeah, so these are kind of limited features that are available on the Purple Air website, but the data as such is completely in the open domain, and it remains there as long as the sensor is active.
Thank you, Prakash. Terry,
Hey, yeah, hey, Jonathan, I mean, you made a great point. I look at this. We have a really big effort in the Triangle region around our stormwater and rain gauge data, and we've created kind of a standard, and we looked for a high level. So like the state has their Fireman's platform that they have, they take in a variety of sensors, and they've created this kind of map and provide lots of data in a useful way. And for us, and I would say from Cary and the other municipalities, well, from a Cary aspect, we adopted their structure for how they're displaying the data and showcasing the data. And right now it's available for staff. Eventually, citizens and outside parties will see that data. But we looked for that high-level guiding light to put the data in a meaningful, useful way. And we've kind of in that case, in that scenario, have adopted what, those parameters, any type of standard we can build against, that helps us build internally, if that makes sense.
Yeah, no, that does make sense. And I think, just the whole thing is just, folks, what confuses the public is the magnitude of the number. Sometimes they ignore the colors. Like the number could be 3 nearby, but it's 10 in their neighborhood, and they say, well, we're more than 3 times higher, and how that's really bad. And in actuality, it's not. And then the other thing is they look at the size of the dot. You're like, well, I don't live, that's not my house, that's not my neighborhood, even though they may be in the next neighborhood over. And they just don't understand that the concentration, may be very similar. So there's lots of challenges with presenting geospatial data.
And I do want to add that the map that I showed, obviously it has sensors that were deployed by others outside this project. So for the sensors that we are deploying as part of this project, we are, like I said, we have calibrated, we have developed calibration factors for each sensor by co-locating it next to one of those reference monitors on EPA's campus. And so for those sensors that deployed by others outside this project, which do not have that, most often the sensors are okay, but the example that Susan pointed out where one sensor alone in the region was red. So that could be either a faulty sensor, maybe a wrong calibration, the sensor going bad, or maybe some particle just stuck in the path of the light within the sensor. So, but yeah, I think that's a very good point in terms of what does it mean in terms of interpreting the data, and how good is the data quality with these data sets. And for our project, we are building a data framework that will kind of take into account the calibrations that we've done and also be able to provide the satellite-based estimates once we relate it to that level.
Thank you for that, Prakash and John. This is really useful information. I think what I'm hearing is several folks wanting to get involved with this regional sensor network to see if the NASA sensors could be applied in their communities. And then maybe there's a larger conversation about a regional network. But I wanted to say, and I know we've just lost a bunch of people, Bob Irvin is leading Jules Accelerator. And Bob, if you want to, I have a couple of slides teed up, but maybe you could give the group here a quick update on cohort 7 that's coming up, because it definitely bleeds into this decarbonization, measuring emissions theme that we've been talking about. If you'd like, Bob.
Okay, you want me to share my slide, or?
If you have them, if not, I have your deck.
I just had one slide to show. Well, yeah, the deck's fine either way. Just real quick to take 1 minute. We worked with a number of scientists and venture capitalists and corporations recently. We built a climate tech hype cycle. And so we looked at all the technologies, where they are in terms of if they're going up, are they going down, are they in the trial? And we kind of ranked them, and there's about 30 of them. And I have that slide if I share my screen. I have don't need it. But we looked at all those companies, and we chose 4 areas to focus on. So keep on flying through if you want to. And there's a lot of trends happening, COVID-19, new funds, but we're seeking for cohort 7, pre-Series A companies that have strong teams. They fit our technologies, which are hydrogen, cooling, carbon sequestration, and climate fintech. So just real quick, next slide shows you, we've looked at about 200, I think right now we have 100 companies that we're analyzing and talking to. And basically, if I had to say what they look like, they've been around for a couple of years. They've raised less than $1 million. 2 of them are located in North Carolina. So we hope to have, skip to the next one real quick. We hope to have a book done at the end of September. Just to give you a quick example, one of the cool companies at Duke University is Carbon Insights, which is kind of an American Express for your carbon footprint. Carboculture out of Finland, and Sky Cool Systems out of San Francisco. But they fit those 4 categories: hydrogen, HVAC, carbon sequestration, or climate fintech. And we've, as I said, we've got about 100 companies, I would say, right now that we're going through details. This is a hot space acceleration in general. I can't believe the number of parties, even from the beginning of the year, that have jumped into this game. So finding quality candidates is a challenge. So we got to continue to focus on why North Carolina is special and unique, and why we can prepare this region to be carbon-free over the next 20, 30, 40 years. And lastly, just to give you the key dates, we will give you our book of top 30 by the end of the month, and then we're going to kick off at the cohort 7. We've got a really good lineup, a phenomenal speaker, which you'll see shortly. But on September 23rd, from 10:30 to 11:30, you'll hear 6 or 7 startups, and you'll hear from some of the renowned scientists on climate change and innovation and early stage startups. So it'll only be an hour. So hopefully you'll get your calendar, mark your calendar for 10:30 on September 23rd, and your book will come around if the extent that you're interested. If you're not interested, because there's some proprietary information in there we have to dumb down occasionally, we'll get that at the end of August, and then we'll pick our top 7 to work with. Thank you.
Thanks, Bob. I'm sorry for saving that important information till the end, but I mean, we've had some successes so far. Like I think with Dynamex working with Duke Energy in several of the cities on this call today. So that's what we're looking for in this next cohort. If you all want to be advisors or potential pilot opportunities for these startups, that would be fantastic. So I have just a minute left. In terms of, I guess, takeaways from this meeting, let's see. I'm not sure that we identified a pilot opportunity quite yet, but we did identify folks on this call wanting to be part of building out that regional air quality sensing network. I hope we achieved our education and collaboration goals. I think our next action item steps would be to follow up the RTI, set up a small group meeting, and then we'll share contact information with you all from San Antonio and CPS and RTI for you all to build those connections. Any other remaining comments or needs from the group? Then the last thing I'll share with you is we have a couple of great education opportunities coming up. Tomorrow, Governor Cooper is speaking as part of the North Carolina Clean Economy Summit. We're partnering with E2 on that. That's tomorrow at 1 p.m. We've also got Duke Energy talking about electrification, transportation. And then on August 25th, we have an economic development focus call around energy and the relationship between the U.S. and Australia for any folks who are interested. So on that note, John and Prakash, thank you very much. Bob, thank you. Thanks everyone for your time today. We'll send out notes and follow-up items. Have a good afternoon.
Thank you. You're welcome.
Thanks, everyone.
Bye, everybody. Thank you.
Thanks. Bye.